right, Precalc, we're going to move into unit vectors. Unit vectors, they're just kind of confusing because, again, the wording in this whole section is really what you need. So let's just look at, it is the vector, and this vector is going to be in component form. So just a reminder that component form is in the carets. So notice right here we have the carets in example 4. And we're just taking that and putting it over the magnitude. So for example 4, we're going to use, I'm going to erase this so we can see everything that it's asking us. We're going to use the unit vectors, and we're going to do it just like this by putting the vector over the magnitude. So let's go ahead and let's dive in and get started. Example 4 says find a unit vector. Again, this keyword unit vector is showing us a number in component form over a magnitude. And it says in the direction of, here we go, 7, -3. Now remind you, when we're given that component form, we can just take 7 squared and add it to -3 squared, and we will get the magnitude. So 7 squared is 49. -3 squared is 9, so it looks like we have the square root of 58. So in order to write this answer, we are literally going to take component form and put 7 over the square root of 58 and -3 over the square root of 58, and voila, we have what we call the unit vector. Now, the last part of this question says, verify that the result has a magnitude 1. So what that means is if I take this result and put it into the magnitude, or what we know as the distance formula, we need to go ahead and show that 1, sorry, I didn't mean to make that a highlighter. We need to make that 1 is equal to, well, we're going to take 7 over 58 squared, sorry, over the square root of 58 squared, and -3 over the square root of 58 squared. And we end up getting 49 over 58 plus 9 over 58, which is the square root of 58 over 58, which is equal to the square root of 1, which does equal 1. So you probably won't see many questions asking you to verify that the magnitude is 1, but remember the magnitude is just the distance formula like we did. All right, so we are going to move into one other funny wording. This is no different than anything that we've done, but it says let U be the vector with initial point -2, 6 and terminal point -8, 3. Write as a linear combination. Linear combination is just like component form, except they have i's and j's. So let's write a little reminder here. Component form has carets. So we typically write the x, y in carets. Linear combination has something I plus something j. So we're going to work with the linear combination. Again, we are going to take terminal, and we're going to take terminal minus initial. So in order to do this, to find the x's, I'm going to take -8 minus a -2, and we get -6. And then I'm going to take 3 minus 6, and we get -3. Now, if we were to write this in component form, we would put that in the carets. So we would have -6 and -3. But remember, they're asking us to write it in this linear combination. So we're going to write it as -6i minus 3j. I have literally seen questions that say, show this component form in linear combination. So again, it's just about wording, definitions, and making sure that you know the answer to the wordings and the definitions. All right, the last thing that we are going to get to today is this one right here, example 6. It says, let u equal I plus j and v equal 5I minus 3j. They want us to find 2 times u. Well, u was I plus j. I'm going to go ahead and write that as a cursive. And we're going to subtract 3v. Well, that's 5I minus 3j. So when I work this out, I get 2I plus 2j minus 15I plus 9j. And my answer is negative 13I plus 11j.